well, here's the thing. She's not going to graduate high school. And they're like, well, she make bed nice. And I'm like, then why does she even bother going to school? Like, what's the point? She could have more time at home if she just stayed. But that's a world that obviously I did not grow up in. So, yes, that was and I don't know why they ended up in.
They're from
I probably asked 400 Somali students, so why did you choose like to go from Mogadishu to Minneapolis? Like it's freezing cold here. Every one of them gave the same answer. Oh, that's where the train stopped. Like every single one of them said those exact same words. Like they had obviously been trained to say that. Like that's where the train stopped. I was like, but it's freezing cold here. Like take a different train. Like, but
which train?
What train goes?
Is there just one train? That's
Express, bro.
Well, you know, in Somalia, they not only have they never seen snow before, they've also never seen cold because it doesn't really get cold in Somalia. And then they moved to Minnesota where it's like -5 for 6 months. And yeah, it's weird because of course they don't have jackets when they get off the train. So, all right, let's do some homework problems. Well, I'm not kidding you. Like Goodwill, Salvation Army, like they just stand at the train stops and just like hand out coats to these people that are wearing like nothing because they just moved from Somalia.
Oh, I have a question.
Did they come from the airport?
What's that?
Do they come from the airport?
Caleb, people that are escaping war don't fly. They take a boat and then they take a train. It's the cheapest way to get there.
I had the hope that they.
If they don't have money for a jacket, why would they have money for an airline ticket?
That's
like,
me.
So good news. If you marry Caleb Neal, he will choose flying over warmth. Flying over warmth. Willow.
You're in the plane with warm. Not necessarily. Sometimes.
Yes, let's take some more questions. Kiwi.
It was on 3.
But Willow's first. She had her hand up first. Willow, what section and what problem? 3-3, number 8 on the AP, and we're in a dark alley. And oh no! Oh no! Okay, so here we go. Here we go. And what do we got to find on this one? So f of x is equal to g's inverse. That's kind of weird because usually you define it the other way. If f prime of 4, find f prime of 4. If g of 4 is equal to 3, Caleb, if g of -1 is equal to 4, g prime of -1 is equal to 5, and g prime of 4 is equal to -1. Ooh, this is a dark alley. Okay, so let's think of, okay, so we take the, yuck. What do we got to do on this one? So g's inverse is f. So if we had f of g of x, ooh, now I'm not going to lie to you, Will. I'm going to have to try this one out 2 ways. I know one of the two is going to work for sure, but I don't know which one's off the top of my head going to work. So f of g of x would be equal to what? X, right, because f is g's inverse. Okay, so we take the derivative. So f inverse, or f prime with g of x on the inside, multiplied by g prime of x is equal to what? 1. Now we substitute in f is g's inverse, but that doesn't have anything to do with what we're talking about here. So let's plug in everything else and see what we can do. So g prime, and we want to know what f prime of 4. F prime of 4. So, so we got a 4 in there. So we want to plug f prime of 4 in. Okay, well, here, ready, set, math. Here we go. So we plug in 4 to g prime first. G prime of 4. So we replace all of them with 4. Ooh, this is not pretty. Okay, g prime of 4 is equal to what?
-1.
-1. G of 4 is equal to what? To what?
F prime of 3.
No, we got to plug this in first, though.
It's 3.
3. G of 4 is equal to 3. So f prime of 3 times that is equal to 1. Let's divide both sides. So we got f prime of 3 is equal to what? -1. Ooh, that doesn't. Well, hold on just a sec. Hold on just a sec.
In the book.
Hold on. Let's think. What does the inverse do?
It switches the inputs and the outputs.
Yes, remember that. It reflects over the line y equals x. Remember the inverse. So if here's the line y equals x, the inverse reflects over that. So if you've got a point here that's at a, b on f of x, ooh, I should use g of x, of g of x, where would the inverse be? That same point would be on the inverse at b comma a. So it would be reflected over here at b comma a. So what does that tell us about this? If we plug in 3 into the inverse's derivative, We plug in 3 into the inverse's derivative. What is that the same as plugging into the original function's derivative?
1/3.
So that's the question again. It reflects through the x-axis. So if we plug 3 into G, no, we plugged 4 into G. If we plug 4 into G, that's the same as plugging what into its inverse?
-4.
Stefan?
Just asking.
Yep.
If you wanted to find f prime of 4, which is what the question's asking, would you
Yep.
want g of something to equal 4, so then you would have f prime of 4 as a term?
Can you say it again? I can't hear you. Caleb's talking back there for some reason. Even worse, he's listening.
If you wanted f prime, if you wanted to find f prime of 4, and you had the equation f prime of g of x times g prime of x equals 1,
Yep.
then wouldn't you want g of x to equal 4? And then you would find whatever that x value is and put it in for g prime of x and g of x.
Yes, I'm trying to figure out how I'm going to get that from 3, though.
That's your back bench.
Hold on. I'm trying to think of how I'm going to get that from 3, though. Yep.
Can I ask you if what I did is correct?
Okay, did you switch? Okay, remember I told Alexis I know it's going to work out one of the 2 ways, but I'm not sure. Did you plug the function into the inverse or the inverse into the function? What's that?
I didn't close. That's the derivative of both sides.
Take the, well, that's what I did.
Oh, you did?
Yeah. Now, here's the question. Okay, let me just try this real quick. I'm going to show you what's going through my head. So I know this is going to work 1 of 2 ways. I'm just not sure which way is going to work. So let me do it the opposite way. So let me plug G into the inverse. What's that still going to equal? X. Let's see if that gives me anything. Because I know one of the 2 is going to work, but I'm not really sure which way we have to start it off to work. Okay, so then I find G prime of f of x times f prime of x is equal to what? 1. Now, no, hold on. Somebody said that's the same. That's not actually the same, because notice I have a different product rule then. Instead of the original function's derivative, now I have the derivative of the inverse out there. Caleb. Well, which one of these 2 do I want to use? I have to use one of the 2.
It's saying that some function f of x is equal to the inverse of some function g of x. Taking the derivative of both sides, we get f prime of x equals 1 over g prime of g inverse of x. And we can use that. I got the answer.
Hold on. How is that going to the denominator?
Yeah.
It goes because of the g inverse of x. The derivative of an inverse function is equal to 1 over
Yes.
prime.
And all I'm doing is then solving that. Same equation, I just got to divide both sides by this.
Okay.
So we can still get that answer from this. So let's see if this takes us somewhere. So again, I'm taking you through my thought process. I know one of the 2 is going to work, but I'm not sure which one of them is going to give me the right setup. So if I plug this in real quick, I want to know f prime of 4. Question, what does x have to equal? So I'm going to show this on, I can show this on real quick. So question, I want this to be inside of f's derivative. And actually, I think I need, yep. Yeah, I'll do that, and then I'll show you which way it's going to work. I need this to be inside the derivative. Question, if I want this to be inside the derivative, whatever's inside has to give me an answer of what? Whatever's inside has to give me an answer of what? 4. Question, which one of these will give me an answer of 4? Okay, so what did I actually plug in for x then? Okay, so x is equal to -1. If I plug -1 into g, it gives me an answer of what? 4, which is what I want to plug into. Say that again. If I plug in -1 into g, what do I get out? 4, which is what I want in here. So it's like I have to go backwards and figure out what do I want in here. So what do I have to plug in for x then?
-1.
Okay, so that's what I had to plug in for x is -1. Now I'm going to ask you the question. Which one of these two do I want to use? The first one that I did right here or the second one? I want to use the first one, right, because I can then get that. So again, here's the process. I know this gives me x for an answer. I take the derivative of both sides. What Caleb did is he just divided both sides by this. That's going to be a step that it doesn't matter if we do it front or in back. Whether I divide both sides by this or I divide both sides by like 7, that's okay. So then I have to ask my question. If I want to find f of 4, I need g of x to give me an output of what? 4. So what do I have to plug in for x to get an output of 4? -1. So really, I'm going to plug in what? -1. Okay, so let's do that real quick. So I'm really going to plug in -1. So f prime of g of -1 times g prime of -1 has to equal 1. Okay. And that was and really what I could have just said like, oh, here's how you do it. But what I'm talking you through is there are two different options. You have to determine which one of those two is going to give you the setup you need. Then you have to determine what did you have to plug in to get this out. What did you have to plug in to get this out?
So why did you? Can we borrow some graph paper?
I don't know if I have any. Actually, if I do, it's on top of that microwave, but I don't know if I have any like readily available. If I do, it's on top of there though. Okay, question, Luke.
Why did you plug 4 in the first place?
That was a bad thing. That was a bad decision.
Yeah, because the book said at x equals -1.
Right, but why did we get x equals -1? Because we want to be taking f prime of,
Yeah.
not 7,
Of
f prime of 4. So what do I have to plug into g to get -4 out? Because then that's also what I plug in for x. Guys, don't talk when I'm talking through our problems. If I plug in -1, I'm going to get f prime of 4, which is what I want to solve for. What do I have to plug in for g to get that? -1. But then I also have to plug in all of the x's at -1. So there's two hard parts of this. There's two different ways to define the inverse, either the function into the inverse or the inverse into the function. Then you got to decide which one of those two gives me the setup I need, which the first one does. Then we got to determine, well, if I want to find f of 4, I need g of x to give me 4 as an answer. It gives me 4 if I plug in -1. Which conveniently then I also know the derivative at -1, and we can go from there. So let's plug in numbers. F prime of 4 times, what's g prime of -1?
5.
Is equal to what?
1.
1. What do you do to solve?
5 by 5.
Let's hope this is one of the answers.
It is. It's C.
C like S. Now, real quick, why did I show you both? Because you do have to make the decision. It could have been equally that they could have given you the information to work the other way, plugging the inverse into the function instead of the function in the inverse. At that point, then you have to work backwards of what do you need to know to find that. Caleb.
That's the easy way I did it. In much less steps.
Okay.
Sure.
Go ahead.
Is that okay?
Yeah,
We're
fine.
not,
okay?
you're not getting paid for this stuff. So.
You only get paid in Steam, actually. You do get slightly paid.
That's it. I just took the derivative of both sides and then put 4 into the function. And because and because we know inverse, it flips it. So g inverse of 4 is going to be equal to -1. So that's equal to -1. And then g prime of -1, we know that g prime of -1 is equal to 5. 1/5 equals f prime of 4. And that was the step.
Your
Right?
number was weird, Caleb.
What?
Your number.
What is your top f prime of x equals 1 over g something?
Yeah, we're still working on numbers.
Yeah, don't worry, it's a hard problem. That's why it's the last AP problem in there. That's a hard problem.
Where'd you get the function?
The what? Wait,
We
what?
weren't given a function.
We were given the f.
You're doing the
Don't
wrong
look
column.
at the two.
No, f of x.
Caleb, hold on 2 seconds.
Oh yeah.
Caleb, hold on 2
Oh,
seconds.
oh,
I'm sending out the remind, but it's going to be on there for a second. Go ahead. Go. I just had to move that.
So f of x equals g inverse of x. Take the derivative of both sides, f prime of x, and then the derivative of an inverse is equal to 1 over g prime of g inverse of x. And then we want that to be at 4, so f prime at 4 equals 1 over g prime of g inverse at 4. So we know that g at -1 equals 4, but because when we take the inverse, the inputs and the outputs switch, we can say that g inverse of 4 is equal to -1, right there. So then if we put 4 in here, it's going to simplify down to f prime at 4 equals 1 over g prime at -1, which g prime at -1 was given to us as 5.
Yep.
So that's going to be f prime at 4 equals 1/5.
In essence, what he just did, though, is took that derivative formula I had and divided both sides by that composite function to get it on the other side. I mean, he just started out with that instead of taking its derivative. Good job. And whether you divide at the start or the end, it's fielder's choice. But there's a reason why that's the harder one. Let's do an easier problem so you don't lose confidence in your ability to understand it. Because that's a tough AP problem. Yep. Kiwi.
On 3-6, number
Yep.
43, my question is why sync inverse
Singe.
Oh, for the other one, for sect, it's actually pronounced sect, I think. I looked it up.
Okay. Kiwi, go ahead.
For cinch inverse,
Yep.
why does it equal 1 over the square root of u squared plus 1?
Okay, let's go through. So g of x, let me start from the start, is equal to x times sine hyperbolic inverse of x. Did I give you that formula?
No.
No.
Okay, let's go through real quick.
In the
Notes.
textbook.
It's in the textbook, of course. Well, actually,
It is.
hold on a second.
The
You said AP
formula
Hold
doesn't.
on.
derivative of cinch inverse.
Look, you actually have to know that for the AP test, because I may have assigned you a problem that I didn't really mean to assign you. Ahem, hold on.
Oh my god.
And the formula's in the book.
You told us that AP.
I know sine hyperbolic, cosine hyperbolic, tangent hyperbolic are definitely on there. There was a problem last year on it. I don't know if the inverses are, though. Hold on, hold on. You're answering a question that I'm not. Yeah, that's not on the.
Okay, so
But it's a really fun problem anyway, so let's do it. So reminding yourself that the sine hyperbolic's inverse, well, let's use u, so it's a composite function. The sine hyperbolic's inverse, if you're in a dark alley one day and you need to know it, is 1 over the square root of u squared plus 1 times du dx. A fun, fun, fun. Now, at the bottom line, this is a what rule problem? Product rule. Is this a chain rule problem? No, there's nothing to chain in. You've got x, you've got x. There's no functions inside besides x. What's the derivative of x, by the way? 1. Because one of you did smartly send me an email. Isn't every single calculus problem we've ever done and will ever do a derivative with the derivative a chain rule problem? Yes. But when it's just x on the inside, what's the derivative of x? 1. So, okay, yes, cosine of x is most technically a chain rule problem. Just we don't write 1 on the outside because what's the derivative of x equal to 1? But yes, if that's a good connection to make. Every single problem we've ever done is actually using implicit differentiation. Every single problem we've ever done is actually using the chain rule. Yes, it is. That's a good connection to make. But, okay, so we go back to the problem. We've got x times sine hyperbolic inverse of x. Well, that's a product rule, so f of x is equal to x. What's the derivative of that? 1. G of x, then really fun, is sine hyperbolic inverse of x. What's the derivative of that equal to? Well, 1 over times the derivative of what's inside. What's the derivative of that? 1. So let's multiply that out. So the derivative, g prime of x, is equal to the derivative of the first times the second, plus the derivative of the second times the first. And then if your homework hasn't impressed your parents yet this year, there's another problem to impress them. Yay.
So we just got to memorize the hyperbolic trig function.
You need to know sine. Okay, let me be 100% clear. You need to know sine, cosine, tangent, hyperbolic. You do not have to know their inverse. You have to know sine inverse, cosine inverse, tangent inverse. You do not have to know secant, cosecant, cotangent inverse. And that's, I know I rarely teach that way, but really what I wanted you to get out of that lesson was memorization, even though the questions you asked, because I've unfortunately trained you better than I should have, the questions you asked were about understanding it. No, you will not have a question on, so in the alternate universe where sine hyperbolic would exist, what would alternate interior? No, you don't have to know that. That was just like FYI knowledge.
So is there any actual real life application for sine, cosine, tangent?
Yes, in fact, Arjun is borrowing my book right now. It's called Complex Analysis. It's a class I prayed a lot in. Both times I took it. Yep.
What class will we learn hyperbolics?
There's a really fun class called Theoretical Geometry in college, where the first day, basically that speech I gave you last time is the speech on the first day. Everything you learned about geometry was just Euclid's rules. Euclid isn't like the founder of geometry. He just founded Euclid's geometry. There could equally be other geometries where parallel lines could be defined in another way, where lines could be defined in another way. Lines could just be the connection between 2 points. We define lines right now as the shortest distance between 2 points. That's what makes them straight. It's the shortest distance between 2 points. But a line could be any connection between 2 points. And then you go home and study that. Another theoretical math class is called abstract algebra, where you theoretically talk about other number systems. Like our number system is base what? 10. What if we change it to base 7? Well, is A times B always equal to A times B times A then? Is A plus B always equal to B times A? Does the distributive property hold?
It's so weird.
Yes. And Josh, then your friends are over like majoring in something really easy like PE and they've done their yoga homework and you're like, and I'm studying, if we looked at matrices in base 7 number systems, is A times B always equal to B times A? And then you're thinking, I'm doing this and they're, yeah, that's why some people make bad choices in college because they don't want to suffer like that. No joke. Or you're like pre-med and you're like in organic chem 2, which is studying crazy aspects of what happens to electrons in non-organic systems. And they're making different life choices that involve them going to bed at 4 in the morning and you're going to bed at 4 in the morning, but for a totally different reason. You've been studying that whole time, and that's when the library legally kicked you out because the janitor found you studying after the library actually closed, and your friends closed down something else. Yes?
Can we buy some chemicals so my brain doesn't fall apart?
Absolutely. They're up there. You could, Willow, it's self-service. You can serve yourself. All right. You want to take a daily? No.
Wait, do you have change?
There's a ton of change in there right now. All right. You want to take a daily quiz or go on to the next section?
Section.
Yay. Take your notes. Let's talk about 3.5, which is linear approximations.
Yeah, that's a fun one, actually. That's like an intro to Taylor.
Should we do a daily quiz?
Well, I didn't know which box.
Any other votes for daily quiz?
It helps our grade, guys.
All right, let's take a vote. Daily quiz. New section.
New section.
Sorry, new section. Linear approximations.
Good.
No, it's just something I know I can probably get a good grade on. So.
All right. Don't forget, you got a test next Tuesday.
Can I go get a drink?
Yeah, on Friday.
Thank you.
That's test Tuesday. Yes.
Also, what was I gonna say? Oh yeah, this is like cool because it's kind of like a not Taylor series, but it's not.
Kind of.
It's a basic introduction to the concept of a Taylor series.
Yes, it is a basic introduction to it.
You should make a reference. That should be like, hey, you guys need to do something like this.
Okay.
Well, if they have something I want.
They don't have like any
I really appreciate it.
You're welcome. All right. Definitions first. Okay, I am gonna.
sell candy for like.
We don't. Hey, whoa. We do not sell candy. No. You can't sell that in school. We sell carbs and chemicals. If you need something to provide you with, oh, I forgot the chemicals. C6H12O6. Yes, for chemistry class, we can help you with that. Or if you need some chemicals to like kill your yard, we can sell those too. But Kiwi, we are definitely not selling candy. We are definitely not doing that. What are you talking about?
I don't know. I just know that lately in Colorado Springs, the ice cream vans have literally been like bomb missiles with like stickers on the side of different ice creams. It's super sketchy. You've never seen an ice cream van?
Okay, so definitions real quick. dy, dx. Notice how we gave you this really sloppily, like in Calc 1, we gave this to you really sloppily at the start of this year, and then we've gotten more and more precise about what this actually means. dy dx is actually a differential.
Does it say linear what?
Linear approximations. We're going to use something called, I should put this up there too. This is called Newton's method.
What did Newton study?
What did Newton study? Even his happiness book sold for $1.3 million this week. So.
Happiness?
Yes.
What is
That sounds so
Yes. Yeah, and you'll be able to do both.
Like he studied happiness?
Yeah, his happiness manuscript sold for $1.3 million on Monday. Handwritten by Newton.
How old was he when he?
Who gets the money?
I don't know. Newton.
Newton's dead.
Newton dead.
When did he?
New Newtons.
My mom's a Newton.
All right, dy dx should be called a differential because we are looking at the difference. Shh, guys. We are looking at the difference in y's change over the difference in x's change. The difference in y's change over the difference in x's change. Which gives you a dy dx, could also be written as delta y over delta x. I hope your Algebra 1, your Algebra 2 teacher told you that. That means change in y over change in x. Another way of defining that is kind of thinking of this as a limit. The limit is h approaches 0 of our old friend f of x plus h minus f of x over h. Now, thinking of that, the top was how much y changed. Approximate, not equal. Approximate, not equal. Some of your parents would yell at me for that. This is how much y is changing. This is how much x is changing. This is how much y is changing. This is how much x is changing.
So you're basically saying everything goes back to limits.
Everything we're going to do this class, all at least Calc 1 and virtually all of Calc 2 is back to limits. That's why I spent so much time making sure you understood them and you knew how to do them. Because I mentioned last year I made a big mistake and just kind of cruised through limits and let people think Boba Betsy was how they worked, and then we got to using limits in infinite series and sequences, and I had to go back and reteach all of the limits, and then they were kind of sick of calculus at that point, so I made a better choice this year. Look,
How can just h be the change in x?
because it's how much x has changed. It's how much difference is between these 2 points. In fact, really, this is x plus h minus x. But when you simplify that out, what is it? Just x. Because we have x, we have some point that's a little bit away from x. When you take x plus h minus x, the x's cancel out and you're just left with the h, which is what it should be. That's how much this has changed. This is the difference between the y value at this point and the x value at this point. Let me draw that out real quick. Let me draw that out. Let me think of a function. Yeah. Let's do it with like something, it's something non-trivial like this. And let's let this be x. This be x plus h, because I think I'm going to want to, spend time to make sure you geometrically understand this before I go further. Okay, a duck question. Delta x, the differential between those points, how far are they apart from each other? H, right. The differential is h. That's how far apart they are from each other. How far apart they are from each other? Well, there is also an f of x and an f of x plus h. That would be like right here, right here. How far apart are those from each other? They're f of x plus h minus f of x. How much your y has changed? Now, what's the calculus problem that's involved with that? We try to make those two as close to each other as possible, which makes the denominator very close to what? As it gets infinitely close to 0, we see how much those two are changing from each other, which gives us our slope, gives us our instantaneous rate of change.
So I have a
Yep.
question. I know that in pre-calc this year they're doing difference quotients.
Yeah, that's because I asked Breebach to do
Why
that this
do
year.
they do that if they're not going to take the limit?
Because I want them used to the algebra part. Even if now remember, you get to it at the end of the year after the seniors are done, but the juniors are still there. You should be talking about limits then. But I asked Breebach to do it this year just so they had seen it before. So I'm not teaching so much in Calc 1, because if I'm teaching you the limit, the difference quotient, and the algebraic process, that's just a lot to digest, especially for the AB kids. It's a lot for them to take in. It's better if they've seen it before. If you had me for honors FST, we did the difference quotient in that class because I wanted you to see it. Only reason. I just want you to have seen it before, so not everything's so new. Why did I spend so much time on the limit on this? So when we go to infinite series and sequences, you've seen the limit part. Now I'm just introducing series and sequences instead of trying to teach both at the same time.
So I told Emily that if she was doing the difference quotient, that's like one step away from calculus.
Yeah, just take the limit. And I feel like I've said that 500 times in this class already. What takes us from pre-calc to calc?
The limit.
The limit. Okay, so let's talk about the relationship between delta x and delta y. Okay, so let's talk about the difference between delta y, delta x, and f prime of x. Okay. Okay, you're really smart. Delta x is something we are associating with dy. Sorry, I said the wrong word. Delta y is something we're associating with dy. Delta x is something we're associating with what? Dx. F prime of x. Okay, how could we find an equation that has all three of them in it? We could take the what of this? Derivative, right. Okay, so take the derivative of both sides. And I know you've done it a million times, but I want you to make a connection that's what's in this section. Okay, now this is the dumbest question ever. dy could also represent the change in what? dy could also represent the change in what?
F of x times.
No. dy could also represent how much what has changed. What value? dy could also represent how much what value's changed. X could represent how, or dx could represent how much what has changed. Kind of weird. If we want to know just how much y has changed, what can we do to solve for that? Multiply both sides by what? Is this a fraction? Yes. Is it the derivative? Does it seem sacrosanct or like against your religion to multiply both sides by dx?
A little bit.
Yeah, but that's got to be something we give away, and that's what that section teaches. If we want to find dy, all we have to do is take whatever f prime is equal to at that point and multiply it by how much the x has changed.
And is that just
This is the differentials equation. I'm going to put it into words too. To find how much y changed, take f prime. Yep, sorry, I'm talking to myself. Take f prime of x at that point and multiply by how much x changed. Now, why would you do that if you didn't want to find out how much y had changed in that function? To find out how much y has changed, take f's derivative at that point and multiply it by how much x changed. To find out how much the y changed, take f prime of x and multiply it by that. What is the part you have to realize? That dy dx is separable. It is a rate of two quantities. Now, why do we introduce it to this point right now? Well, what's coming up in the next chapter? Related rates, which is why we take those rates and we relate them. Part of understanding that is this is two values that are separable from each other. dy and dx can be separated from each other. Okay, what does that lead to? A local linear approximation. A local linear approximation. And Luke, you're actually going to get your daily quiz today anyways. So. Leads to a local linear approximation. Now, I'm going to back up for just a second. 3.1, 3.2, 3.4 are all sections about how to take the derivative. Where were inverses 3.3? 3.3? Yeah, 3.3 is about how and what the inverse is like. 3.6 is a little math theory. And 3.5 is a preview. What this section is getting you to do is think about what we're going to do in Calc 2. I debated, in fact, those of you that saw me downstairs, I was actually debating if I was going to cover this section today because it's not really needed for today, but it's needed for later. But I can afford a day today to get you a preview of what's coming. It's about locally estimating a function. It's about locally estimating a function. And it's also about the concept of relative error. Both of those are really minor topics in AB, but they become huge topics in BC. At this point, they're willing to invest some time to talk about like how far off we are. How far off we are. We put 1, 3.2, 3.4 are all about how to take the derivative, how to take the derivative log, how to find the chain rule, how to find implicit differentiation. The vast majority of your tests is on those 3 sections. 3.3 is how to do the inverse. 3.6, all you really need to know is what the derivative hyperbolic sine, hyperbolic cosine, hyperbolic tangent are. Just like 3.3, all you really need to know is how to find the derivative of sine inverse, cosine inverse, tangent inverse. 3.5 takes a look at this linear approximation. We're at a thunder time, so we're at a 40, correct? I'll talk about this for about 2 more minutes, and then I'll start it when we come back on Friday. What we're trying to do with this. What are we trying to do? We're trying to make a function linear for a small area of f of x. So in other words, from like x is equal to 0 to 0.5. Why does that come up later? Because this is the preview of what's called a Taylor series. Your calculator has no idea what the sine of 2 is. What it does is it knows a very small number around 2 that it can find a series to do that with. What linear approximation does is attempt to make a nonlinear curve linearized in a small area. Some people call, and other books call this local linearity. You see that word on the AP test once in a while. These problems do take a while, and I'm not 100% sure I can finish one in 15 minutes, so I'm actually going to stop there for today, and then we're going to start with the problem at the start. I'll even tell you what we're going to do. We're going to do f of x is equal to x times e to the x. Is that a straight line? No, but we're going to try to make it locally linear between 0 and 0.5.
Is that our first example?
That's what I'll start our class with next time. But I'm not 100% sure, and I don't want to leave this one midway because you'll leave with a very unsatisfied taste in your mouth. Sort of like chemicals give you. Okay, so let's take a daily quiz. All right, take your test. Back and length between you, person sitting next to you. I got it.
I don't understand why.
What's that?
Why
So far away.
Because it's what's the best behaved function you know? And it's nice because what's the slope of a linear function? Constant for the whole thing. So what we're trying to do is find a slope that would be a constant for an entire area of a nonlinear curve. All right, take out a sheet of paper, share it with the person next to you. Let's take a very quick daily quiz. Numero uno. Oh, Napor, easy or hard one?
medium?
Medium, x squared times the sine inverse of x. What is dy dx equal to? And number 2, let's go for, oh, I don't know, e to the, oh, yes. F of x is equal to e to the x. Cinch. Cinch of x. What's f prime of x equal to? Oh, do I want to do anything else? I feel like I wasted 2 days covering something. It's a very minor detail, but minor detail it is.
What's today's date, 25th?
Today is the 25th. Yep. Real quick, those of you that are in IB that went through the DP track for this, I have like 50 meetings coming up about this. Are you glad you took BC or do you wish you would have taken AB?
I'm glad it's BC.
I
No, I'm
took-
glad I took BC.
I'm just, Jenna, you know, this is, if you're in debate, if you're in debate, this is what type of evidence?
Not in debate.
Not in debate.
This is anecdotal evidence. Like I know a guy. Like you can't talk to the guy, but I know a guy that's right, and you should believe me. This is anecdotal evidence. It's the lowest form of evidence because nobody else can verify it but me. But I heard a couple of you. If you went the DP track, basically we're always, because you know DP kids have the least flexible schedules ever, but we try to cram the most into you we can while you're here. So I do want to make sure that what we're offering is meeting needs. Are you glad you took BC, or if you could do it over again, would you have taken AB? Or it's just Beckman's a total jerk, and as long as he doesn't teach it, I can do that. Yeah.
I'm glad I'm taking your class, but I do wish I would have taken AP.
Okay. If you knew I was teaching both, would you have taught AB? Taken AB? Okay. Now in my head, I have ideas of who took DP, so I'm kind of looking at you. But if you're not a DP student, just shake me off because I have the wrong idea. Yep.
I really enjoy this class because it's a lot more challenging. And
Oh yeah.
I like challenging.
Yep. Like I'm not covering this in AB. In fact, did you talk about local linearity last year in AB? Yeah. Anybody else that took the DP route to get here? Will?
I'm glad it's BC.
Okay. Yep.
Same with Willem.
Yep. Lena? Okay.
I wish I took AB like last year instead of DB.
But you can't get your diploma if you take.
Yeah.
Margaret's getting her diploma.
Okay.
She's
Better.
a special case.
Yeah.